and we have a mismatch of here we are returning the integer type, and here we are returning the unit type. When we don't return anything, we return unit type. It is like it's not explicit, but under the hood condition is just returning this thing. Hey all, hope you all good and doing great. In this episode, we are going to start with our new topics, which is related to functions, control flow, and all the subtopics that are in it. And now let's start with the episode. And actually, what we are going to start with statements and expressions. So in all of the other languages, you might have noticed what statements and what expressions are, but in this video Rust deals these things in a little different way. So how Rust deals, let's explore. And in general, what statements are the things that don't evaluate to something or don't return something. So we can just simply write statements are the things that just don't return anything. These are just simply these statements. If I take example of this is the example, like if let x is equal to 6 and then semicolon. This is just a simple statement in Rust language. And if I now talk about what expressions are such things, are such statements. Actually we can't call these things as statements, but expressions are such lines written in the language syntax which evaluates to something or can return something, return any value or anything. So these are called expressions. Like we have a let's just ignore this example now and let's focus on this example. We have let sum is equal to 5 plus 6, and this is the thing which is being evaluated, 5 plus 6 to this variable. So this is an example of expression. And now if I look at this example, this is a let expression in the Rust language. We have a variable let y is equal to this curly brackets closing at this, and then we have this statement. One statement is here and there is one expression is here. If you don't put any kind of semicolon at the end of any line, then this line is called expression, not the statement, because we currently don't have any kind of semicolon at the end of this line. Now this line will be returned from this curly bracket scope, and this y value will be holding at the end of this line what x is 3, and then we adding 1 in this x variable. 3 plus 1 will be 4. So at the end of this line, if I say at this point y will be holding 4, now we can say this all thing is an expression, not a statement. This all in this box, this all is an expression, not a statement, because this is just returning something. And if I put any kind of semicolon at the end of this line, now this whole statements, this whole box is not returning anything. It is not evaluating to at some point and not returning anything to y. So this is a statement in Rust language. We will call this as a statement. Now have a look at this example. This is very important with respect to interview perspective. Now interviewer may ask what's the difference between these two statements, this one and this one. Even these are written same. If let me ask you something, is this an expression or statement? You will say this is a statement, as we already discussed here. Like if let x is equal to 6, we write like this. This is a statement. This is totally fine. This is a statement. But is there anything in this statement which is called expression? Yes. If we focus on this 6 is still itself a value which is being evaluated to x, this x. So this 6 is a expression itself, but this whole line is a statement. That's why I have like I have wrote it down on this side as well and on this expression side as well. So now let's move to another example in Rust language. If I write this these lines here, let x is equal to y is equal to 6. In JavaScript, this statement is totally valid in JavaScript language, and in some of the other languages, these kind of statements are valid. And if I write in this way, let x is equal to 5 and comma y is equal to 6, this statement is also valid in some of the other language. But in Rust language, these two lines are not valid at all. And if I give example of like this, let x is equal to 6 and let y is equal to 5, these two lines and these two statements are totally valid in Rust, because whenever you have to create some other variable, you can't do in a single line. Here we are initiating and defining variables in a single line, and this is what you can do in Rust, but you can do in some of the other languages, but Rust don't allow. So this was another point, and this statement is also not valid in Rust, because this is something you are calling as an expression, and then you are giving its value to this variable x. Like you are saying to Rust, hey Rust, just take it this y is equal to 6 as an expression and assign it to x variable which is written behind this. But Rust cannot do this, because Rust take this like line and this segment as a statement, and you can't assign a statement to some other variable. So that's why this is not a valid syntax in the Rust. All you have to do is to do this, to like define some of the multiple variables, and if you want to like give a value of y to x variable, what you can do is x is equal to y, and this you can only do this if these both statements have same data types here, i32 i32. Like if you don't, as I already mentioned in previous videos, if you don't mention any kind of data types with the variables, Rust will like on itself will guess the data type of variable on the behalf of this value that you have given. If you have given like some kind of float here 6.3, what the data type here can be, it can be like f32 or f64. So Rust guess itself data type of the variable if you don't mention on the behalf of like these values that you wrote here. So now let's move toward the code editor and see some of the examples, all of the concept that we have discussed here. So now let's just create a new project here, or you can say new folder via using cargo new command, and make sure you have to have in this directory, in this root directory where we have these all previous folders here. So I am in this root directory, and cargo new episode 3. Okay, we have just created this, and let's now change the directory into this new project episode 3, and yeah, that's it. Now if I go to in this directory, and here's the our fresh main.rs, and now let's talk about this main function. As this episode is dedicated to functions and control flows and all of the subtopics in these like major topics, so this is the entry point in our main.rs file, and all of the other functions that you have to call just have to go outside of these functions, and you can call inside these functions. Like you can also have in this function, if I have some another function here, and then I just call this, you can do totally, it's totally good and correct. And but what's the best practice that we do is just call the function here and define function outside of it. So this is something that you can do easily. Yeah, this will work fine. So main is our like entry point, and all of the things should go in this main what you want to be processed. So okay, So let's take another function called like student age, and just call it out here and define it outside this main function. And this can be all of the function statements, function definites should be start with this fn, and just define this function. Copilot is helping us, which is great. So now I have to pass the argument here, which is 18, and I have to print it out here in this function age. And if I save this file, this project, this should not process at all if I run this in the terminal. Let's run this cargo run, and this should throw an error via saying like couldn't compile due to previous error. And what this previous error is, we have to mention the type here. Like this variable should have type here, which can be i32, as this variable is 18, so this can be i32, or you just say u32, whatever you want. Let's just save this and run it again. And if I run it again, this should be compiled properly, and here I see the student age is 18, which is now working fine. So what Rust do here is, Rust demand from you that you must mention the type of the parameter that you are putting here in the function signature. So you must put the data type of the parameter here, and so this thing will not confuse Rust compiler or Rust runtime when you are compiling the code. So Rust will easily assess that this variable have this specific data type, and this should be the same in the entire file, and this will not change. So this give more certainty to Rust compiler, and hence of course it like reduces the error. So the data type should be here in the function signature. And what if you don't know what function signature is, this is an important concept related to theoretical interview preparation. Like what the function signature is, signature of the function consists of three things: function name, function name, parameter name, and the type of parameters. But I think this is Copilot is being confused a little bit here. So function signature consists of function name first of all, the second thing is number of parameters, and the third thing is types of parameters. Function name, first one is function name, and the second one is number of parameters, and the third thing is type of parameters. These are the three things that function signature consists of. And if you change the position of parameters, it don't affect. So now let's have quickly some examples of what the things that we have discussed on our whiteboard related to statements and expressions. So if I write it down, the example that we took there, that x is equal to y is equal to 10, and try to compile this, compiler will throw the error on this statement and will not build this up. Cargo build, and this will be panic here, and it is saying that you have to have let statement here as well. So let's have a let statement here as well, and this will not, I think, compile as well, because this is not a this is not a correct syntax, as we already mentioned on our whiteboard. So what you have to do is you have to have variable on another line to compile it properly. So this is the thing with this multiple variables on this single line. You can do that, you have to do this. And now if I go to second example, let's have let's comment this out and have y is equal to this thing. And if I write it down here, these statements, and now this is not a statement at all, this is a expression, as we already discussed, because this thing is just returning something to x, which is evaluating at the end. So yeah, this is like just that's it for this You can also have some example at your own and can practice this out. I think we don't go like too much into these details because we have already discussed this on whiteboard, so we don't want to waste our time on these things. And now let's talk about return statement or return value of the functions. So if you want to return anything, like if I am getting age here, and if I add and manipulate something in the age plus 1, and or I like don't manipulate and just have a statement here via giving this keyword here, return age, and I try to compile this git build, this will not compile because this have to have what this saying is specifically expected these unit type and found u32. But this unit type is whenever you don't return anything from here at this level, function will consider that you are returning these empty brackets and Rust call it as unit type. So we have to return, we have to give some data type here and have to describe that we have to return something, and what we have to is u32. So if I save it and just run it again, it will so it's again complaining something what expected because of default return type student age helper consider using a semicolon here, expected this, found this. Okay, so now if I try to build this again, this will again not work. Even we have mentioned this type here, return type here, this will again not work because this is here at this line, this is expecting something to be returned and evaluated to some variable or some at some other point. So let's save this return type in x variable. Now this will work fine because we are saving this value in another variable. We are storing this value in which is returned by student age. Now it's not complaining at all. So there is an other way of returning value from a function. If you don't want to put any return keyword here, what you have to do is just define or just put the variable or the value that you want to return at the most ending of the function, and don't put any kind of semicolon, because we have already discussed this thing that if you don't put any kind of semicolon, this thing will be returned and will be considered as evaluation as an expression. So this thing will be evaluated and considered as an expression, and now I can call this line here, student age 18, this section here, that this is an expression, not a statement, because this function is evaluated to something that is being returned here. So this line is not a statement anymore, as it was already not, because we were returning something. So whenever you return and it eventually evaluates to something, so this will not call statement, this will call expression. So if I save this and run again, this will work fine, and we are having x value in this. If I just print it out here and just comment it out, this line, and cargo build and cargo run, this will print the statement student age is 18, which is being printed out from here. So this is all about function. Like there are some of the things that we will dig down in the future episodes, but for kind of at upper layer, this is all with the functions. So now let's start with our next topic, which is control flow statements and all of the other stuff. And by the way, I will not explain these kind of minor things like how to have comment in the Rust language. Of course, I am having comment from the next episode, so you should know, like, to comment out any line, we should have these two forward slashes. Or what you can do is just to have, as most of the other languages do, is just have these kind of gestures, slash and then asterisk and then closing a stack, closing static and then forward slash, and all the things inside this will be considered as comments. So we don't have to waste our time in these kind of minor things. So let's move to our next thing, which is control flow. So let's have another function here named control flow. By the way, Rust preferred this semicolon, this snake case, like separated with the, not semicolon, sorry, underscore, all of the names separated with underscore, which is called snake case. And you can also have this like camel case, but Rust prefers this, as this is the convention in most of the Rustacean developers. So we will also of course follow this convention, because this will be easy to understand for you whenever you will look at someone else code, because he or she will be using this underscore snake case, and this will not like conflict in your mind to get this point. So this is the function for control flow, and we will play with all of the control flow in this function. So let's take some example. If statement, if else, if I take example of if else here, yeah, this is what exactly I want, and Copilot is helping me. So this is the thing, like I will not just write these statements down, because these are the same as some of the other languages. Like what are the important points, I will only discuss them. So let's have an example here. Rust prefers to not have parentheses around these conditions, but you can put the parentheses and you can compile and build the code like having parentheses. But what the convention in Rust community is just to avoid these parentheses, because most of the other languages have parentheses, but Rust community don't prefer these parentheses because this is the convention. So this is just simple if else statement. If this condition becomes true, then this statement will be run, and if this becomes true, then this will be run, and otherwise, and if not, none of these statements run, then at the end this else will be run there. And like this is just easy concept, you know, in this happens in all of the language, so we don't have to waste to write any of the times on this statement. But the most important point to discuss here is it's just single point. Like unlike other languages, Rust have to have bool here. Like whatever condition you have to be here should be in a boolean. Like it should be either false or it should be true. It should be a type of boolean. Like let's suppose I have a variable here, x is equal to 10, and if I have this if condition like having if x, then print this out, this will not work, because this x is not a type of boolean. This is a type of I32, or you can say U32 here, because Rust automatically guess the types. So this must be a I32 if we don't mention the data type, and this if expression will not run at all, and this will throw an error. So this must be a boolean. And if what we have to do is to run this statement and to not throw this error, I have to mention x should not be 0. This is what you can do here to avoid the errors. So now this condition is evaluating to be boolean. So this was the important point here. So now let's move toward another example. If in, let me have a section here, if in let statement. So what this actually example do is, in this example we can use our if else condition via in a let statement, and if I use this syntax, then we can have this let is equal to number here, and this statement will be evaluated. As we have already discussed, we are not putting any kind of semicolons here, so these numbers are being returned from this if condition now here. So as we have this condition true here, so what will happen, this condition is being true and 5 will be returned, and let's check it out what we are being printed in this number variable. So if I run this out, so by the way, to run this we have to call this in our like main function, and just comment out and just call this out here. And if I run this now, what we will get is okay, so yeah, you cannot use, I think, this double. Yeah, now it's not complaining because you cannot use double equal here. So you must have to have only single equal, or you can do this. Okay, so now if I see at line 47, what we have is the value of number is 5. As this condition was true, so this is being returned from here to this. But let me try to have semicolon here and save it, and this will, if I try to build here, cargo build, this will complain me. Expected unit type and found integer. Cause what's happening here is in this section you are not returning anything, and what this section of if statement is returning is just this unit type, and we have a mismatch of here we are returning the integer type, and here we are returning the unit type. When we don't return anything, we return unit type. It is like it's not explicit, but under the hood condition is just returning this thing. So there is a mismatch between data type, so that's why it's being complaining here. Now what we have to do is to remove this error. Either we have to just remove this semicolon, so to make these both of numbers data type same, this integer, this one integer, either we have to do is to not return anything from both of these sections. So if I save and build this, now this will not complain for like this will not complaining for these data type, but it's complaining here because we don't have any kind of like anything in this number. So now it's working fine. And yeah, this was for like if else statement. And now let's move toward our next topic, which is loops, and just revert it back to previous condition so we can have some output here. Okay, now if I try to run this will work fine, and we will have value of number is 5. So now we have our new topic, which is loops, related to loops. And the most simplest loop that we have in Rust, it is just a loop. Like it's written in like this syntax. First we have a loop keyword, then we have our blocks, and we write anything that we want to write here. By the way, this loop is run at infinity until you have any kind of break keyword in the loop. So if I just paste this script again, and if you can see, whenever this counter will be equal to 10, we will like break it out. We will break it out this loop here, right at here, at this condition. So this is the simplest loop that we have. Otherwise, if we will not give break, it will loop iterate like rest at the rest of the world. So let's move ahead. The other loop that we have is like while loop. And how while loop works in like Rust, this is just like a straightforward way. In Rust we don't have like do while or any other kind of while as other languages have, like C++ have. We only have this one. So this is just a simple like just a simple loop having condition here, and you can just iterate over it, and wherever you want to break, you can just break it out. So this is just a while loop to iterate on something if you want to. And the most like precious loop and the most useful loop in Rust is this for loop. And this for loop iterates over arrays, and whenever you want to use this for loop, what you have to do is just put this for keyword. Then what this is doing, let's dissect it. Actually a is an array, and to operate on for loop we have to create an iterator. Like you will be thinking, we already have an array, what's the need of iterator there? But this is how for loop works. You have to have the iterator to operate on for loop. So this is actually for in loop. You can say it for in loop because it iterates over each of the index. So here we are creating the iterator. Just simple task. We will what we have to do is a dot iter here, a dot iter, and call the method. It will create the iterator for you. And what will then for loop do is, on each iteration, this one of these items are being consumed by this variable, this element variable here. This element picks up each of the on each iteration one element from the array. This element variable on each iteration pick up the one element from the array. Like if I just rename it item, this will be a good renaming. So what this item variable is doing is picking up each of the element from array at each iteration. So and it is being printed here. If I just run cargo run, then element, oh sorry, we have changed the name of variable, so we have to change it here as well. So this loop will be printed out here. Oh okay, so this is here, this is just being printed out here from each of the index. So that's it. And by the way, this for while loop, you have a condition here. Whenever this condition will be false, it will be just break down, and you are just subtracting it out this number. You have a 3 on each iteration, you are just making it like 1 less. So first iteration it will be 3, then will be 2, then 1, and then 0. At 0, like it will be just break it down. So when it will not 0, it will just loop through, and whenever it will become 0, it will just get out of this loop. And this is all for the loops. And by the way, one little method, if you want it to be reversed, like you want it to be printed from end to start, what you can do is rev, you can use this method here, and you all go. So that is it for this video. We have like explored a couple of things of Rust, and thank God we didn't go into like too many details, because these are the things that are like every language holds. But in the next video there is a like very interesting topic that's my favorite. We will discuss it out, which is ownership in Rust, and this is the core and heart of the Rust. So we will discuss it out, and see you in the next video. Bye bye.